Hi, my name is David Piorkowski. Today I'll be giving a talk on how AI developers overcome communication challenges in a multidisciplinary team, a case study. We motivate this work as follows. We know that AI developers are experts in data science. We also know that external stakeholders are experts in their own respective fields, but they're typically not data science experts. This difference in skill creates a knowledge mismatch, and that knowledge mismatch between AI developers and their external stakeholders further leads to communication gaps between the two. We have observed that AI developers are the ones that are typically left translating data science concepts for their external stakeholders, and they already do this rather effectively. So the question here is, how can we better understand the techniques that they're using so that they can be applied somewhere else? To get at that goal, we focus on two research questions. The first is, what are the key communication gaps that AI developers faced? And the second is, how do AI developers overcome these gaps and communicate across roles? To answer these research questions, we use the following method. We interviewed 4 AI developers from IBM. The individuals we interviewed were not part of an embedded data science team. Rather, they would rotate from team to team and problem solve using AI. After completing their solution, they would hand it off before migrating to the next team. You'll notice we also use the term AI developers instead of data scientists, because our study allowed for participants that were data science adjacent in addition to traditional data scientists. One such role was a strategic consultant who acts as a bit of a mediator or bridge between the business side and the data science side, yet still has a fundamental understanding of data science. We performed interviews in 2 stages. In the project overview stage, we asked participants to describe the team, the project, and how roles jumped in and out during the AI development process. In the follow-up artifact in-depth phase, we asked participants to bring in artifacts that they used to communicate to non-data scientists and had in-depth talks about each one of those artifacts. Artifacts included slideshow presentations, software repository readmes and wikis, collaborative online document editing software, and software documentation, including more long-form technical documentation. All in all, we ended up evaluating 8 communication artifacts. Shown here are the aggregated results from our first interview, the project overview phase. Across the center in gray boxes from left to right are the phases of the AI development lifecycle. Underneath each of these are the roles that are involved in each of the phases. Both the roles and the participation in phases were defined by the participants. There are 2 key observations here. First, no one role participates across all the phases, but the data scientist participates in many of them. Second, many roles drop in and out multiple times throughout development. Taken together, it is unsurprising that teams end up relying on data scientists to maintain the shared mental model about a project. In those same interviews, we addressed the question of communication gaps, and we found that AI developers' communication gaps broadly fell into 3 categories, as seen on the right. They are knowledge gaps between roles due to mismatched expertise, establishing trust across disciplines, and setting and managing stakeholder expectations. We then use principles from shared mental models theory as a lens to understand both the gaps faced by AI developers and the solutions that they employed. Let's take a moment to review the mental model principles that we use to guide our analysis. The 5 principles are as follows: consistency, reactivity, proactivity, coordination, and knowledge stability. Consistency is the ability to maintain stability by resolving conflicts due to differing perceptions, different knowledge states, asynchronous information, and missing updates. Reactivity is the ability to effectively address unanticipated events or state changes by informing team members of those changes and adapting goals and plans to account for the new situation. Proactivity is the ability to anticipate problems, bottlenecks, and failures and take proactive actions, such as asking for clarification or offering assistance. Coordination is the ability to work together via overall cooperative attitudes, such as establishing joint goals and plans, transparent task assignments, and truthful information sharing. Knowledge stability is the ability to understand the staleness of information over time and adjust sampling rates according to confidence and the information's validity. We now look at how participants address those communication gaps, starting with the principle of consistency. At its core, consistency is about maintaining a shared knowledge state. We observed how the asynchronous nature of the work and the balance of data science skills caused the team's shared mental models to fall into conflict. One approach participants used to maintain consistency was by answering questions from other roles. In some cases, participants proactively consolidated information into a shared resource. Here's what one data scientist had to say. It started out more with them just asking questions, and I would have meetings to respond to those questions, things like that. But maybe after 2 or 3 of those meetings, I started to realize we're kind of getting the same questions repeated. So I thought it might just be easier to get all of them in one document so we can share that. Answering questions was just one way that consistency played a role in maintaining shared mental models. Other examples include contextualizing data science results to stakeholders' use cases, education of data science terms and practices, keeping terminology consistent between presentations, and repetition of key ideas. Here's what our data scientist said regarding context and use cases. I think these examples were chosen intentionally because for the stakeholder team, this use case was a really big one for them. So it is something that was on the forefront for them. And because we thought this was a relevant example for this audience, because that was something that they were focused on. Now let's turn over to the principles of reactivity and proactivity. Uncertainty is a given when building intelligent systems, and it requires teams to respond to that change. Reactivity is responding to unanticipated changes, and recall that proactivity is about responding to anticipated change. Some of the data scientists proactively documented models to anticipate stakeholder misunderstanding and more easily foster discussion. So here's what strategic consultant had to say. So I guess the documentation is high-level business and high-level technical. So hopefully, regardless of who the person is, they can get some kind of sense of what's happening here. Let's take a look at a real-world example of both proactivity and consistency from one of the artifacts shared by our participants. On the left side, you'll see an explanation that one participant used to quickly explain the different parts of a confusion matrix. In it, he shows that the true positives and true negatives are part of the correct match, and false positive and false negative are not. This participant talked about he would continuously reuse this icon and others like it in his presentation week after week to help stakeholders recall exactly how to interpret not only a confusion matrix, but other complicated data science ideas. In conclusion, our paper had the following results. We identified 3 key communication gaps that AI developers face, including specific real-world examples of how those gaps arise and how they are addressed. We've also shed light on how and why AI developers cross communication gaps using shared mental models as our lens to inform understanding. We also describe the best practices in the AI development workflow and provide insights to those who are interested in alleviating the communication gaps that AI developers face. More details are in the paper. I'd like to close with a quote from a strategic consultant that captures the essence of this research and serves as a call for help. I've been working with this project for so long. I could easily kind of dump out information about it. It's just a matter of how do you go about this. If there's some kind of template or tool to show me exactly what I need to make, that would save me a lot of brainstorming. Thank you.